Welcome, boys and girls, to your video lesson on angle relationships, as well as, angle relationships. It's going to be great. So you can classify angles and identify vertical and adjacent angles. So just naming angles and their relationships with others. So here are some vocabulary words for 10.1. Angles, degrees, vertex, congruent angles, right angle, acute angle, obtuse angle, straight angle, vertical angles, adjacent angles. They all have something in common. They have to do with angles. So, an angle has two sides that share a common endpoint that is measured by degrees, okay? So if you have a circle that's total of 360 degrees, you can break that circle up into angles, you can see, and that creates right there. So different spaces. So each part, if I broke it into tiny little slivers, would be 1 degree. The point where those two line segments meet is called the vertex. And here, we would call this angle, we call it several different ways, but we would name it in front by using this angle symbol. And different ways to name it you will see below here. Well, I can show you this one first, too. And then you can try those. So 4 different ways. I could call it angle Y. Well, in this case, I can only name it 3 ways right now because there's no number inside. Angle Y, because that's my vertex. I could name it angle XYZ. Notice that Y, where that vertex is still in the middle. Or I could name it angle ZYX. As long as that Y is in the middle, you're set. So there are 4 different ways to name an angle of this variety. One is to name it by its number. So here I have angle 1. Or its vertex is B, so I could call it angle B. Or I can name it angle ABC. Or in reverse, angle CBA. Okay, noticing that B, that vertex, is in the middle. Why don't you try this one? And then come back and see. So this could be angle 2, angle S, angle TSR, or angle RST. Easy as that. So other things, angles are classified by according to their measurement. So their degree measurement. 2 angles that have the same measurement are called congruent. Remember, the symbol for that looks like an equal sign with a squiggly on the top. Okay, so that is congruent. Same measurement equals congruent. So here are the types. You're going to want to write this chart down in your notes. Different types of angles. So you have a right angle that is exactly 90 degrees. Notice it'd be 1/4 of a circle. 1/4 of a circle right here. 1/4 of 360 would be 90. That little mark denotes 90 degrees. Less than 90 degrees is an acute angle. I always think of acute as small, like a little mini fun size candy bar or baby shoes. So cute. They're acute shoes. They're little. So that's less than 90 degrees. Obtuse is big. It's between 90 and 180. Okay? Whereas exactly 180 is going to be a straight line. And that's what those are picked as. And you can just name them as you see them using that chart. So we are supposed to classify, which means name, each angle as acute, obtuse, right, or straight. So when I see this mark there, I know it's 90 degrees exactly. So that is a right angle. Here I'm noticing that this is not a 90-degree angle because that would be if it was extended. So it's less than 90 degrees. So this is an acute angle. This one I notice if I made this 90 degrees is much larger. So this is an obtuse angle. So I kind of use that 90 degrees as my reference point. And I see this one is perfectly straight in either direction I can make it. And you know 90 plus 90 is 180. So that's exactly 180, and this is a straight angle. Ta-da! All right, so some more vocabulary. Vertical angles and adjacent angles. Vertical angles are 2 angles that are opposite of each other, across from each other, when 2 lines intersect. So for example, here, angle 1 and 3 are vertical angles. They're across from each other on those intersecting lines. They're going to be congruent. They're going to have the same exact measurement. And angle 2 and angle 4 are across from each other. They are also vertical angles that have a congruent measurement. Key concept, you're going to want to write this down. 2 angles that are adjacent, they share a common vertex, a common side, and do not overlap. So they're next to each other, okay? So, for example, in this example it says 1 and 2 are. Notice they're next to each other. It also says 2 and 3 are. they're next to each other. They share this common side. 3 and 4 are next to each other, sharing that common side. And 4 and 1 are next to each other, sharing that common side. So each of those pairs are an adjacent pair. In an example like this, 5 and 6 are adjacent angles because they are next to each other, sharing this common side. So in intersections, now you're just identify, which is name, the angles in the diagram that at the right, and then justify your response. So what I could say that 2 and 4 are opposite, formed by an intersecting two lines, so that's my explanation, so they're vertical. Similarly, 1 and 3 are vertical because they're opposite each other. So my justification here, because that's important to do, that they're vertical, is that they're opposite of each other when two lines intersect. That's an example of how to do that. What I could say the question was asking me to describe my some adjacent angles. I could say, for example, angle 2 and angle 3 are adjacent angles. They are on Garfield Road, sharing the intersection of Lane Avenue. So they share that common side. Okay, so looking at this one, we're going to refer to the diagram here and identify each of the following and justify a response. So for E, we are being asked to find a pair of vertical angles. It could be any pair that is vertical of each other by intersecting lines. So I'm going to go 3 and 1 because notice they intersect by these two lines right here and they're congruent. So angle 3 and angle 1 are vertical angles. They are opposite of each other. When two lines intersect. And for F, it says a pair of adjacent angles. So this has a variety as well. So I may pick 4 and 5, or 3 and 2, or 1 and 2, really any that are the same. So I can pick angle 4 and angle 5 are adjacent because they share a common side and vertex. Yay! Excuse my writing with my terrible stylist. All right, so that was angle relationships. Now we're going to look at angle relationships that are complementary and supplementary. So identifying those and then finding missing angle measures should we need to. So a little bit more vocabulary. So complementary angles and supplementary angles. Key concept, you want to write this down. Okay, so complementary. Complementary, the sum, meaning the added together of two angles, measures to 90 degrees. Okay, so that's going to look like this. The sum of the measures is 90. It doesn't always look like a right angle right away. Sometimes it's going to be two that are separate, and if you put them together, they would equal 90. So it can look like either example. So think complementary corner. I always think when I write out complementary, if I put a line down the C there, that makes a 90. So supplementary are two angles, not three, not one. They're two angles that have a sum that add up to 180. So measures that add up to 180. So that means that they'll form a straight line if you do put them together. But again, it could be two separate angles that you add their measurements for 180. For that one, when I write supplementary, I put a line down the S and it makes an 8. So I think complementary corner, supplementary straight. Okay? Remember, if I'm going too fast, you have the power over this video to pause, to rewind, to write down whenever you feel appropriate, okay? So classifying, naming each angle as either complementary, supplementary, or neither. Maybe they don't add to any. So what you can try here is, do they add up to what? So I add 60 plus 30. Since that equals 90, those two angles, since there's two and they have a sum, are complementary. Here, 85 plus 90 is equal to 175. That doesn't equal 180 or 90, so those are neither complementary or supplementary. Noticing angle 1 and 2 create a straight line, makes them supplementary. And then adding 75 plus 15 here, those equal 90 degrees. So if I put them together, they'd equal that right angle. So these are complementary. All right, finding the missing angle measure. So we just need to know, we're going to apply some algebra here. What we already know when we look at a right angle is that they're supposed to be complementary. So that means the angles are supposed to add to equal 90. So what I notice is that angle ABC, which is right here, has a measurement of 28 degrees. And I know that that measurement plus angle CBD, which is right here, should equal 90 degrees. Well, CBD is a value we don't know, which is x, and that should equal 90. So I know that without that 28 degrees, solving an equation here, the remaining part should be set equal. So that means that that is 62 degrees there. One little word, perpendicular lines form a right angle. So AB is perpendicular to DB here. Okay, so find the missing angle measure. Try it on your own. For this one, find the value of x. This is a separate one. So I noticed that these are forming a straight line, so I know that 46 degrees plus whatever x is should equal supplementary, which is 180. So without that 46, my variable then should equal 134 degrees, which makes sense since it's obtuse, it should be more than 90 degrees. You could always plug it back in to check to see if you're right. Now one where I might have to draw a picture. If angle J and angle K are complementary, so that word right there tells me that angle J plus angle K should equal 90 degrees. Then it tells me if angle K is 65. So all I do is replace angle K with its value. And it says, what's the value of J? So that's what we're looking for. So you can leave it like this or replace it with a variable. And that just means that without that 65, the remaining is the measure of angle J, which is going to be 25 degrees. So that says the measure of angle J is 25 degrees. A lot of information, a lot of breezy information. Just as long as you have things written down, you should be able to reference them whenever you need and be successful. Good luck.